Alrighty, in these problems, guys, we've got two tasks. We need to identify what type of reaction it is, so it can either be, and let me get started with this, there are 5 different types of reactions that they can be. They can be synthesis reactions, and we just write an S for that. They can be decomposition reactions, and we just write a D. They can be single replacement. They can be double replacement, or they can be combustion reactions. And so for the first one, if you notice, and I like to kind of draw similar to what you have in your workbook, but you've got SB, so I'm going to draw one atom here. You've got one thing, and it's being added to another thing's being added to it, even though, I mean, these aren't actual atoms. I'm just showing two different things. And what you end up with is those two things that are now combined to make one thing. And so if that happens, if you take two separate things and you combine them together to make one product, that's going to be a synthesis reaction. All right, I'm going to come back and I'm going to balance in 1 second. I'm going to keep going on. In number 2, I've got two different types of atoms. So it looks like that. And then next to it, I have two different atoms. I'm going to treat PO4 like one thing. I'm going to treat H like another separate thing. So here's H. And I don't know, let's make PO4 this. And if you notice, what happens is that these guys are going to completely switch partners. So PO4, which is my like dark blue circle theme above her, is going to bind to, now I'm not going to be able to find the color, to zinc, which was the lighter blue color. Okay, and now hydrogen, which is my pink, is now going to bind to my Cl, which was my green. So if you look at this just kind of drawing-wise, what's happened is they've completely switched their partners. While light blue and green were together and pink and dark blue were together, now light blue, this guy combined with this guy, and this guy with this guy. And so you're completely and totally switching up partners, so that's going to be double replacement. Okay. And I'm going to come back again and I'm going to balance in a second. In number 3, I have potassium, which is all by its lonesome. Oh, so sad. And then you've got you've got magnesium, which is bound with bromine, Br. Okay. And what happens in this type of reaction, if you notice, K is going to go in, and it is going to literally kick out the magnesium. So now K is going to be bound to Br. Oops. And then magnesium is going to be all by itself. So K went in, displaced magnesium. This is a single replacement reaction. It's like an awkward love triangle where one person's all by themselves and there's a couple, and this guy comes in and says, oh, I'm going to kick you out. I'm now going to be with this person. And now you're going to be all by yourself. And in number 4, what you have is you've got a hydrocarbon. So anything with hydrogen and carbon, okay, reacts with oxygen to produce always in this type of reaction, CO2 and H2O. So this is a combustion reaction. All right, so now I'm going to go through and I'm going to actually balance these guys. For number 1, I've got 1 SB on this side, 1 SB on this side, so I'm good for right now. Here, however, I have 2 Cls and 3 Cls. So if I've got 2 and 3, I'm going to want to make them equal, and I'm going to make them equal by making them equal to 6. So to get this to equal 6, I need to say, okay, what times 3 equals 6? And that's going to be 2, so I'm going to put a 2 here. For here, what times 2 equals 6? Well, that's 3. The last thing is by putting the 2 in front of this entire compound, which you have to do. You can't just place a 2, in between or anything like that. You've got to put it as a coefficient in front of the in front of the compounds. I now have 2 SBs because there's an implied 1 right here, so I've got to put a 2 right here. And now I'm balanced. For the next one, I've got 1 zinc here, but I've got 3 zincs here. So what I'm going to do is I'm going to put a 3 in front, and that gives me 3 zincs, 3 zincs. Now I've got 3 times 2, I've got 6 chlorine, so I've got to put a 6 in front of HCl to make that 6 chlorines. And now I have 6 hydrogens. I have 3 hydrogens right here, so I've got to put a 2 there because 2 times 3 is 6. And then I've got 2 PO4s, and you can treat PO4 like one entity because if you notice on both sides, it's still PO4. I haven't changed anything. So I've got 2 PO4s here, and I've got 2 PO4s here. That's why you need the parentheses so that the 2 can be applied to both the P and the entire PO4. So I've got 2 PO4s here, 2 PO4s here, and I'm finally balanced. For the next one, I've got 1K on the left-hand side, on my reactant side. I've got 1K on my right side, my product side. I've got 1mg, 1mg. I've got 2 BRs here, but only 1 BR here. So what you've got to do is put a 2 in front here to make it 2 BRs. But that then messes up my Ks. I've now got 2 Ks here, so I've got to put a 2 here. Okay. So the next one, when I do my combustion reactions, I do carbons, then hydrogens, and oxygens, CHO, as I call it. So first I've got to do my carbons. I've got 8 carbons here, only 1 carbon here. Remember that 2 only applies to the O, not the C. There's an implied 1 here. So I'm going to put an 8 right here. I've got, for hydrogens, 18 here, 2 here. So I've got to put a 9 in front to make that 18. And that's going to create a huge problem for my oxygen. So let's figure it out. I've got here on this side, I've got 8 times 2. I've got 16 oxygens here. And I've got 9 oxygens here. As soon as you realize that on the product side, on the right-hand side, I need 25 oxygens because I've got 16 plus 9. I have 25. That means that I'm going to say, okay, what times 2 equals 25? And you can either say 25 over 2 or 12 and a half. And we can write it right here. Don't just say, oh, I can't do this problem because it's a decimal. You can do it. We just can't leave it like this. What I would love to do is just multiply the 12.5 by 2, but unfortunately if I did that, my oxygens would no longer be balanced. What I can do very conveniently is multiply everything in this reaction by 2. If you do that, I'll show you, you still stay balanced. It's really cool. So there's an implied 1 right here, so I'm going to make this a 2 because 1 times 2 is 2. This was 12 and a half. I'm going to multiply that by 2 and make this 25. Okay. This is 8, so 8 times 2 is 16. And then here, 9 times 2 is 18. And what you'll realize is, okay, I've got 2 times 8, I've got 16 carbons, awesome. I've got 2 times 18 hydrogens, which is 36. 18 times 2, I've got 36 hydrogens still. Here, I've got 50 oxygens. And what you'll see here is that 16 times 2 is 32 plus 18 oxygens here. So that's a total of 50 as well. So now I'm balanced, which is super cool. So remember, don't be afraid of the decimals if you're going to have to do it. If you have an odd number like 25 oxygens on one side, just put a decimal, put the 0.5, and then multiply everything by 2. And you'll be good.